In today's episode, Wanda asks, how do I know if my A-B test is statistically significant? This is a very good, very common question, particularly with things like web page optimization and email marketing and even social media marketing. What happens is we'll get results back. In fact, let's do this. Let's show you an example here. This is an A-B test I did yesterday. And what we see here is I sent out an email, 2 different subject lines. Subject line A was 8 steps to improving your LinkedIn profile, and B was a question: is your LinkedIn profile working for you? And we see in my marketing automation software here, this A here has been marked as the winner, right? Let's look at the stats. When we look at the stats, we see A was sent to 39,574 people. B was sent to 39,573 people. So far, so good. A got 3990 opens, which is what I was measuring on. B got 3873 opens. So A is the winner. Or is it? To answer Wanda's question, this is a very common scenario. What we need to do is we need to do some statistical testing. We need to do what is called a proportion test first, which is a 2-sided test. And then we need to do a power test to figure out whether our sample here is large enough. Some basic stats. When we're talking about these statistical significance tests, what we are talking about is there enough of a difference between A and B that it could not have happened randomly? It could not have happened by chance. Is there a difference enough in the audience that you could measure it and say, yeah, this is not chance. This did not happen by accident. It was a real impact. Or could this have been noise? Is there enough of a difference that that's so small that it could have been random? And that's really what we want to find out, because if we want to make a judgment about is subject line A or B better, we need to know if A, in this case, which is the winner, really actually won, or just luck of the draw. To do this, there are a number of different ways that you can tackle this in every math and stats program available. I'm going to use the programming language R here. Again, there's even web calculators for some of this stuff. I just like to do it in R because it's super compact. I have my A population, which is the number of people sent it to, and the number of opens that A got. I got my B population here and the conversions, and I'm going to run that proportion test. What I'm looking for is this number right here, the p-value. A p-value of under 0.05 means that there's a difference. There's a big enough difference between the two that, gosh, something has happened that is meaningful. Here, it's above 0.05. It's at 0.164. So these 2 audiences maybe have behaved the same, which means that A didn't necessarily win. Now, just to show you an example, what if I take B down to 3,400 conversions, right? If I do that exact same test and run it, we see that the p-value shrinks to an infinitesimally small number, E minus 10, right? That's 10 zeros before the decimal. That is a clear difference that the result was not random luck. But now if I crank up B to 3,900, make it super close, right? Watch what happens. 0.851. That p-value has gone up even higher. And so, just with this very simple mathematical test, we can determine that in this case, the test itself was not statistically significant. Now, here's the other catch. One of the things that goes wrong with a lot of A/B tests, particularly with social media marketing, is that there's not enough of a result to know. So in this test, we see here about 10% of people opened the email in each category. Is that big enough? Is that a meaningfully large enough size of the audience to tell? To do this, we're going to run this power test. And the power test says that out of 3,900 people, in order to achieve a minor measurable effect of some kind, I would need to have at least 200 people take action, which is that N2 number there. If I did this test and 39 people clicked on A and 38 people clicked on B, would that be enough to judge whether there was a winner? The answer is no, because there's not enough people who have been sampled to give that determination. I need to have at least, just call it 200, round it up, 200 people in order to know, yes, this is a real significant value. This is really important because when we talk a lot about smaller populations need bigger samples. So let's say that I want to talk about the Fortune 500. How many people, how many CEOs in the Fortune 500 would I need to survey in order to get a meaningful result? 322 of them, right? Because it's such a small population that there's a variation. There could be enough of a variation in just a few people to really throw things. So in this case, I would have to survey basically 60% of this very small population to know, yep, there's a real thing here. The larger the population gets, assuming it's well sampled, the smaller my sample size needs to be with regard to that population in order to get a statistically meaningful result. Because again, there could be small variations in a very small population that could throw really big changes, as opposed to a bigger population where you're going to have more of an evenly distributed result. My friend Tom Webster likes to call this like soup, right? In a large population, if the pot is stirred well enough, a spoonful can tell you all you need to know about the soup. But if you've got like a gumbo or a stew, one spoonful may have like a huge chunk of beef, and then you would draw the conclusion this pot is full of beef. Well, no, it's not. You just happen to have a very lumpy a sample there, and so because it's smaller, that those lumps could be more confusing as to the composition of the entire soup pot. So these are the two tests you need to run. And again, there are plenty of web calculators out there that do this stuff. The challenge is here, a lot of them don't do the second part. They don't do the power test to determine whether your sample was big enough in the first place. They just do the first part. So know that. And in this case, if you can use the R programming language or SPSS or SAS or Stata or any of these stats tools, do so, because you will get better answers out of them as long as you can know what you're interpreting. But that's how you know if your test is statistically significant. Big enough sample and meaningful enough difference. If you have follow-up questions about this or anything else, please leave them in the comments box below. Subscribe to the YouTube channel and the newsletter. I'll talk to you soon. Take care. Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.